All right, hello there, friends. I am going to walk you through your output page today because it has to do with chemical equations. Now, we really haven't looked at chemical equations yet because it's more of a chemistry sort of thing, but I did just want to introduce this to you and walk through our output page together. So what we're going to be talking about is something called the law of conservation of matter. I may or may not have said this in class yet, but it was this guy who came up with that theory. And he said matter, mass, can never be created nor destroyed. It can only change arrangements or state, so it can only change forms. So what we're going to be looking at, or the chemical reaction we're going to be looking at, is the rusting of iron. So with a combination of iron, water, and oxygen, we get rust. Now the reactants, or my inputs, are going to lead to my products, or my outputs. The first thing you need to do on your output page is record the law of conservation of matter, which you can find right up here at the top. Okay. Then we want to record the reaction of rusting of iron into the output page of our notebook. So we want to record this chemical reaction into our notes. Now what we want to do is we are going to dissect this and we are going to compare the amount of inputs versus outputs, or the amount of reactant versus products. So first thing I gotta do is let me get my pen going, and let's look at iron. Okay, so we have iron and iron, so that's one element in my equation. Looks like I have hydrogen and I have hydrogen. And then it also looks like I have oxygen on both sides. It looks like those are my three elements that I'm going to be looking at on both sides. So iron's pretty easy because it has a 4 in front of it. Now, if you pretend like there's a 1 here and you distribute this 4, 4 times 1 is 4. Now the good news is, if you aren't a math guru, as long as you have 4 on this side, the law of conservation of matter states that we should have the same amount of iron on the other side. So again, if we do the same thing, let's say I put an imaginary 1 there, okay, and I distribute my 4, I'm going to have 4 irons. Now we're going to do the same thing for hydrogen and oxygens, but I wanted to walk you through this because I know that you look at this and it's kind of intimidating. So you're going to do the same thing with the 6. Remember how we distributed the 4 here? You do the exact same thing. Distribute your 6. So what is 6 times 2? 12. Okay. Now we go over here and we have hydrogen and we got a 4 out here, so we're going to do the same thing with that 4. But now there's also a 3 here. We're going to have to distribute our 3 too. So if I do 4 times 3, that gives me 12. Now again, if you aren't a big math person, if we figured out that there's 12 hydrogens over here, again, we should know that there's 12 hydrogens over here because of the law of conservation of matter. Matter cannot be created nor destroyed. It just changes forms. Now let's look at oxygen real quick and we'll be done. So I've distributed my 6 over here. I'll put my imaginary 1. So 6 times 1 is 6. Now remember, I have another oxygen over here, and it's 3 and 2 this time. So I'm going to distribute my 3. So if I have 6 plus 6, that gives me 12. All right, and now over here, do the same thing with our 4. We're going to have to distribute our 4, and we have our 3 again. So 4 times 3 is 12. Now, if you don't understand any of the math that I just did, all that I need you to get out of this is if you compare the amount of inputs versus the amount of outputs, you should take note that the numbers are exactly the same. although this side, the input side, looks way different than my output side, you end up with the same elements or the same amount of element on each side. Okay, and this is a law. Okay, this is the truth. This is something that will never change. Okay,